Okay, I'm going to show you some examples how to factor by removing the greatest common factor. So first one we'll look at is A. So we take a look at the numbers, so 10, 8, and 2, and we think what's the largest number that we can divide into 10, 8, and 2. So obviously that would be a 2, so we take a 2 out. Now we take a look at our variables. So how many A's can we take out of all three terms? Well, we can take out at least one A. And then for the B's, we can take out 2 B's from all of them. So this right here, that would be my greatest common factor for this trinomial. Now we want to see if we take that out, what will we be left with? So the way you determine that is you divide. So we go 10 divided by 2 is 5. A cubed divided by A is A squared. And B squared divided by B squared, well they just cancel out. So now we go to the next term. So 8 divided by 2 is 4. A divided by A is canceled out. And B cubed divided by B squared is just 1B. And then finally the last one, 2 divided by 2 is just 1, which we don't really need to write. So we'll look at the variables. A divided by A is canceled out. And B4 divided by B2 is just B squared. So now we factored it by taking out the greatest common factor. Okay, let's take a look at B. So this time it's a little different. We notice we have 4 terms. So that means we're going to be factoring by grouping. So we take a look at the first 2 terms and we notice that there's nothing in common with 5x squared and 18y squared. And there's nothing in common with the last 2 either. So that means we need to rearrange it. So we can rearrange the terms in any order to get like terms together. So why don't we have like 5x squared, maybe 15xy squared, and then these last ones. So negative 6x and 18y squared. So again, we just rearranged it. So now that we can get these two to have something in common, and then these two to have something in common. So now we're going to factor them individually. So the thing that's common to these first 2 terms would be a 5, as well as an x, and then we divide to see what's left. So 5x squared divided by 5x is just x, and negative 15xy squared divided by 5x is negative 3y squared. So that one's finished. Now we take a look at the last 2 terms and we see what's in common. Well, we can take out a negative 6 from both of them. And then we divide. So negative 6x divided by negative 6 is just an x. And 18y squared divided by negative 6 is negative 3y squared. So the whole point of factoring by grouping is we want these 2 binomials to look the same, which they do. So now we see what's the same on the left side and the right side. Well, they each have an x minus 3y squared. And then if we take that out, we're left with 5x minus 6. And we're all finished. Okay, let's try a couple more. So this one here, it's kind of like the grouping, except it's already factored. So we notice that x minus 3 is similar to 3 minus x, but they're not quite the same. So this one is x minus 3, and this is negative x plus 3. So to get this one to look the same, we're going to have to factor out a negative. So if I take a negative out, I'll just rewrite it. We'll have 20x, x minus 3. So if we take a negative out, this will become a plus 4. This will become negative 3. And this will become plus x. So now let's see. So now it's x minus 3, x minus 3. So now they're the same. So now we can take out an x minus 3 from both sides. And then we're left with 20x plus 4. But we're not quite done because this second binomial, it has something common that we can take out of both of the terms. We can still factor out a 4. So x minus 3 is as far as we can go. In this binomial, we can take out a 4, and then we're going to be left with 5x plus 1. So let's rewrite this so it looks nicer. So it'll be 4, 5x plus 1, x minus 3. And order doesn't matter for the binomials and the coefficient, as long as the signs are appropriate. Okay, last one here. This time it's different. It has a fraction, so we never want to have fractions in a polynomial like that. So right off the bat, we know that 4 over 3 is going to be part of my greatest common factor. They each also have a pi. And then we can also take 2 r's from all of them. So let's see what's left. So we go 4 over 3 divided by 4 over 3. Well, that cancels. Pi over pi cancels. And r cubed divided by r squared is r. Now I'll go to the next one. So negative 4 divided by 4 over 3 is negative 3. Pi over pi cancels. And r squared over r squared cancels. So we are finished, and we notice we have whole numbers inside here, which is what we want, fractions to be outside. So that's factoring by taking out greatest common factors.